Even though there is a 1, this is still not 1 fraction equals 1 fraction. So I still need to, I cannot cross multiply this, okay? So my first step is going to be to 1, remember that is a fraction, and 2, my next step is going to be to find a common denominator. And to find a common denominator, I'm going to factor. So what I'm going to do is I'm just going to rewrite this problem with all of the denominators factored as much as I can. Okay, now I have several choices, and I don't care which method you like. You need to own it and pick one that works for you. I tend to like to find a common denominator and multiply by the common denominator so I don't have any denominators anymore. But what I've seen a lot of you do is just multiply each term by what's missing. That's what I've seen a lot of you do as well. And that's fine. That's just a different method, and that's fine. So I'll probably do both just so you can see both for this one. Okay. If I were doing method 1, the first thing I would come up with is what is my least common denominator? Well, looking at 1, x plus 6 times x plus 1, my least common denominator is going to be x plus 6 times x plus 1. That's the denominator that each of those terms can go into. So what I'm going to do now is, if we use method 1, I'm going to multiply every term in the numerator by x plus 6 times x plus 1. So in the numerator only, I'm multiplying x plus 6 times x plus 1. And in the numerator only, I'm multiplying x plus 6 times x plus 1. So I'm multiplying only the numerators, and I can only do this if it's an equation. Otherwise, I've changed the fraction. Now, what that leaves me with is this first one. I'm going to have x plus 6 times x plus 1 because really the denominator didn't matter to begin with. In this second fraction, what I'm going to be left with is minus, because this was a minus, x plus 5 times x plus 1. And in this third fraction, the other side of the equal sign, all I'm going to be left with is 5. Well, what that means I need to do now is I need to FOIL these two different binomials together. So I'm going to get x squared plus 7x plus 6 minus, and I am going to put parentheses around the second one because we know when we subtract something, it can be messy. I need to make sure I remember to distribute that negative. So I get x squared plus 6x plus 5, and that equals 5. Now what I'm going to do is I'm going to distribute that negative through. And whether you do this in one step and combine your like terms here, or you do it in 2 steps, that's up to you. And now I'm going to combine like terms. So I have an x squared minus an x squared. That's going to go away. I have a positive 7x and a negative 6x, which is going to leave me with 1x. And then I have a positive 6 and a negative 5, which is going to leave me with a positive 6 and negative 5 is plus 1 equals 5. And then I'm going to subtract my 1, and we get x equals 4. And x equals 4 works because it does not make either of my denominators or any of my denominators 0. Okay, so that's one method. Now, I have watched a lot of you use a different method, and that's okay. Let's see if I can scoot this over. Still keep. Okay. So a lot of you on this, we still need to know our least common denominator, which is x plus 6 plus times x plus 1. But in this scenario, what I would need to do is multiply the numerator and the denominator of each term by what's missing. And I'm going to do that to all the terms by what's missing. This was minus x plus 5 over x plus 6. So this fraction is missing the x plus 1. That's a 1. And then this fraction is missing nothing. So I multiply the fractions by only what is missing. And so doing so, I get x plus 6 times x plus 1 over x plus 6 times x plus 1 minus x plus 5 times x plus 1 over x plus 6 times x plus 1, that's the whole point of this, equals 5 over x plus 6 x plus 1. So the whole point of this method is to get it so they all have the same denominators, because when they all have the same denominators, I can ignore the denominators, and then my problem becomes just like what we did on the other side, x plus 6 times x plus 1 minus x plus 5 times x plus 1 equals 5. And I'm not going to resolve the rest of that from there because it's the same as the last problem. But pick the method that makes the most sense to you. I don't care. I genuinely do not care. And if you have a tutor or somebody that said, oh, hey, try it this way, and you like that and it makes sense to you, go with it. That's fine. The goal is to try to get x by itself. The goal is to try to solve for x, not to do it the exact way Mrs. Allison told you. Right?